So now we understand that we have three options: applying for tender MS1, applying for tender MS2, or applying for MS1 and 2. Here also it says that we cannot apply two at the same time with different prices. So there's only one choice. We can only choose one choice, and then of course we cannot apply for it on simple different prices. So now let's try to fill all the information that we already collected, that we already have in there, that we already examined. So the tender of cost, the cost of tendering, remember this one is money that I will already I need to apply for it. I need to pay. It's, let's say, let's take it as a ticket for going into the stadium. Regardless your team win or loses, you still have to pay for that ticket to go in. Then on top, if you lose, you still have to pay 18,000. Let's say you bet on that. Let's take it as a betting. Okay. So in this case, we have 50,000 for applying. That's the tendering cost for contract MS1, and then you have, if you lose, then you have 18 to pay. Oh, sorry, if you get awarded this project, you still have to pay for the material, the component supply cost, which is 18,000. Okay, so everything is gonna be calculated in thousands. I just put 50, but that is 50,000. So for the second one, we have the cost of the tendering contract is 14. So ticket for entrance is 14, and then if I get awarded, I have to pay for the material, which is 12,000. And then we have, for the last one, we have ticket to enter, or the tendering cost, as 55,000. And then if we get awarded this one, we have to pay 24,000. Okay, so now in this case we have already the cost of the tenders, and then we have to see how much money we can make for each one of them, meaning how expensive we can sell it, and what is the likelihood, the probability that under that price will get accepted. So let's look at MS1 only. In MS1 only, it says I have two options: set a high price for it, 130. I can tell the government this project is $130,000, and the likelihood that is happening is only 20%. That means 80% is not likely to happen. Where do I get this number from? Say, Professor, where did you calculate that? No, I didn't calculate it. It's already established by the company. Already has done some previous projects, and they already are very experienced on that, and they already know what the likelihood of it's going to happen. So in this case, for example, I got for the first one, so I have 130, right? And then I can also do it for cheaper. I have two options. Only for MS1, I can also cheaper at 115. Okay, so in this case, I need to fill those numbers first, all the tender prices options. If you realize, the lower the price, the higher the likelihood to get that award. But we have to think as a company. Companies don't just want to sell cheap their products just because they want to get a contract. Sometimes they have to see, I have to choose what is more convenient for me, the best likelihood and the best profit. And that is what we call the expected monetary value. So in this case, we have, for this one, we have for MS2 only, we have 70, 65, and 60. So we have, firstly, we have the first option, first tender is going to cost 70, and then 65, and then 60, right? And then we have 190 for the last one, and 140,000, okay? So we have in tender 1, 2 options. In tender 2, 3 options. In tender 3, 2 options. In this one we have expensive and cheap, high, middle, and cheap, high, and cheap. Okay, so now let's fill the probability. So that means probability always happens, everything happens 100%. Okay, everything fulfills 1. So in this case, we have this probability. So this MS1 is 20%. So we're gonna put here 0.20, and then the likelihood that it won't happen, you see, is not here. What? So that means if 20, yes, that means 80, no, right? So we have to put that here, 0.8. So we have to fill so that this together, this one plus this one will always make 1. It cannot make 2, it cannot make 3, it cannot 0.5, always 1 because probability is 100%. So let's go for the next one. So 85, 0.85, it may happen. 0.15, it may not happen. And then we have 70, 0.15 may happen. 0.85, it may not happen. That was 70, 65, 0.80 may happen. 0.20 may not happen. So there's always missing. So you have to always complete. Okay. So in this case, for example, like I said, then 0.15 is a no. Then 0.85, 0.85 is a no. Okay, so that's why I'm filling the remaining. Even the information is not given, we calculate because it's always like that. So we have 60, so 0.95 and then 0.05. So you're gonna say, Professor, then why don't we go just quickly to this 1.95? It is more likely to happen. Yes, but it's the one that makes the least money. So let's try to do an assessment of what really is better. Before jumping into conclusions, let's do the whole calculation, do everything by itself. All right, so this one we have 190, so we have 0.05 and 0.95, and then we have 0.65 and 0.35. Okay, so there is 1. You see, always must make 1. So anyway, so then we have it. Okay, so we have already the probabilities. And then let's jump to the next video. On the next video, we're gonna be calculating we're gonna be calculating how much we make or how much we lose out of that. Okay, so let's jump into the next one. No, let's continue with this video anyways. Otherwise, I have to edit it and upload more videos. Let's go over this one. So in this case, what we have, let's start calculating. Here, let's say the gross profit. Let me put here gross profit or loss or net loss. Okay, so in this case, the easiest to calculate is how much we're gonna lose if we don't win, because if we win, we have to do a calculation of the profit minus the extra costs, right? So let's go first for all the losing values. Okay, so in this case we have in not number 13, if we lose 50. In not 15, if we lose 50 also. In not 17, if we lose 14. I'm going to explain that later. Don't get nervous about it. The same thing in this one, we're going to lose 14. And then in this one, we're going to also lose 14. Okay? So in the next not 55, if we lose, straightforward, we lose 55. And also on that option, straightforward, we lose 55. So that means this one, if we don't win, we immediately will lose 50. Okay? So now let's look at the profit. If we earn, how much we earn. Okay? So in this case, I have my tender price, which is the gross money I will get, gross money that I will get, minus the tender, because I had to pay for it on my own, minus the cost of material, which is the CC. Okay? If you got it right, you should have 62. Okay? This one already calculated quickly because I already have the formula. You won't have the formula. I'm going to remove the formulas for you. So in this case, we have it. Now the same thing. We're going to do the same calculation in here. So we're going to go equals. In this case, we have the price of 115 minus the ticket cost or the application minus the material. That is if I get accepted. Okay, so it's 47. Okay, so you realize in this one I make more money, but the probability of getting that is lesser. And in this one I have probability is bigger. Profit is bigger, but the profit is lesser, but the probability is lesser. So let's continue doing that one all the way. So in this case I have 70 minus 14 minus 12. Okay, then I have equals 65 minus 14 minus 12. And then we have equals 60 minus 14 minus 12. Okay, good job. So then we have there one more time. Now we have to do it for the following nodes. So this one, a very high profit minus also a high application cost minus the material cost. You see this one very high, but the likelihood that it happens, very little. So that's not a good business. Already we can see it. This one, 140, also a good money minus the application cost minus the cost of material. No, I don't know why I made a mistake. Because I made one minus plus. Sorry. So we have there, and then we have to multiply those numbers times the probability. Okay. So in this case we have here we have here, which is this cell or this value multiplied by 2%, 20%. Okay, so it's gonna give us that. So what I have to do is equals whatever I find in this one multiplied by this one. Okay, good. And then we have this one, and this one in here. Okay, so in this one there's here one slight mistake. I had to put minus. Sorry, it was minus. I had to put here all the minus 50 because it's minus, otherwise it's not gonna give us a real one. Oh, sorry, minus 50. In here we have to put it negative. Okay, minus 14 minus 14 minus, that could change everything, that's why minus 55. Okay, so in this case we have this one also multiplied, whatever I find in L8 multiplied times J8. Okay, so what I do, I'll just do it for you just because I'm doing that. You already know how to do this. Whatever I find in this one times whatever I find in the probability. So in this case I have the value times probability, so it's 12.4 and minus 40. Don't pay attention to that because what we have to know is the expected monetary value of the whole node. Okay, that means of node number 2. It zooms down to only one value. So in this value, what I have to do is the sum of this one plus this one. That's it. Okay, mine is already calculated because I already did it in advance. Otherwise it takes me another 10 minutes to do the video, but you can just do it on your own. So one more time. So in this case, like I said, let me do from the scratch so you can understand that. Okay, so one more time, I have take this value, which is the gross profit or the net loss, multiplied times the percentage. Okay, and the same one, this one, net loss multiplied times this one, because it's the likelihood that I will lose. Okay, then once I have that one, again I have this one plus this one. Okay, so there we are, and already everything is calculated exactly in the same way. Okay, so when we look at this one, we have to look which one has the highest expected monetary value. Means which one has the highest likelihood of winning, plus it has the highest profit. So when we look at this one, what we can say is the best one will be, well, I'm just gonna highlight this, 32.45. Okay, now in this way you can say, Professor, so this is the best option because it's the most money I can make. Yes, but in this case also we were looking at the case study, and in the case study it was saying also, it was asking downside and upside. So the downside is that once I go in, if I don't get it, I'll lose 50,000 pounds. So in this case is when you can say, so what's a better option? We don't have, we as a company, this is the most expected monetary, the biggest expected monetary value, right? So that's the best option. And yeah, that sounds all right if you have those 50 million to spare. But if you don't have those, if you don't have those 50 million to spare, then that's not a good decision. So you have to say, well, we're a bit short on cash at the moment, so we only have 20 million. If we go for 50 and we don't get it, we're in big trouble. So let's look at something that perhaps has less investment, less initial investment. So then we can look at this one and we can say, well, then 31.6, it's okay. Well, I can make very similar money as this one. You see, this one is 32,000 and this one is 31,000. But the difference is in this one, if I lose, I just lose 14,000. That makes a very big decision, right? And say, well, it's better to make 32 by losing, make 31 by losing 14 than making 32 by losing 50. Okay, so in this case we have to think that in terms of our initial investment, the money that we have to enter this transaction. You look at this one and you can say, well, this one, for example, this one has much more earning, but the probability is too little, so that's not a good option. This one, the same thing. Also, we can make more money, 61. But the problem is the probability doesn't help us. So that is, again, well, you always have to take a decision and think about what is the downside and the upside. You have to not just look at the statistics and the number. Yeah, by number this sounds great, but do you have those 50,000? No, I don't have them, so better I go for another option, right? So that changes everything. So let's look at that. And then in your assignments, as says, a consultant has approached your company and with an offer in return for 20,000 cash, means maybe she wants a bribe. She will ensure that if you tender 60,000 for contract MS2, only your tender is guaranteed to be successful. So from this one, let's say for example, you have the 60,000. Where is the 60,000? 60,000. Okay. And let's say, for example, she says, give me 20,000 more and I will make it happen. So in this case, I can add 20 to 12 and it's going to be 32. And then already everything changes. Okay, let's just look at this one. This one, it says 12.6. So my expected monetary value is not that good. I mean, see, it's gonna happen, but still the highest was this one. So there's no point of bribing her. That doesn't work very well. I already gave you the answer, but I shouldn't have. So in this case, you see that changed already. Actually, it lowers your expected monetary value. So that's not a good thing to do. Okay, very good. So with that one, we're ready. And well, in your assignment, give me a minute. In your assignment, you're going to be doing something very similar. So you have to consider the different transactions that you have to do, which one has higher risk, lower risk, possibility, probability, and then from there you will suggest which is the best action, which is the best option, and what is the downside and the upside. So you have to do something very similar, and you will do it from scratch. This one you're also going to do it from scratch. I give you all the calculations, but the one that I'll give you is just has the boxes. It has no calculations whatsoever, so that you get into this as soon as possible. This is gonna come in your final exam. Learn how to do it, and it carries a lot of marks of your final exam. Different case, but pretty much the thematic is the same. Okay, so make sure you understand that.